So the next tool that we're going to talk about today is advanced cluster management for Kubernetes. So we're moving into the Kubernetes space strictly here. Well, not completely strictly, because we're going to talk about Ansible and how we can reach out. But what this brings to the table is, you start with one cluster, you need to move to 2 to 3 to 4 to 5 to 1,000 to 2,000. Advanced cluster management by Red Hat is your tool for doing this. It is split into a bunch of life cycles that we're going to go through today, but there is cluster lifecycling, so creating clusters, upgrading clusters, deprovisioning clusters. There's going to be policy, security, compliance, configuration of your cluster. Again, you can start with one, or it could be 10, or it could be 20, or it could be 100 or 1,000. And then we have application delivery. So how do you deal with application delivery in the cloud, et cetera? And then observability, when you start to talk about this fleet of clusters that are running thousands or hundreds of thousands of pods on them. How do we search for errors? How do we find links? How do we visualize and get through our infrastructure? We're going to take a look at all those different pieces. But as well, we're going to talk about how we use Ansible or leverage Ansible in all of these to reach beyond the Kubernetes infrastructure. And so the things you'll see with Ansible today are integrations, which are very much an outbound, where we're using Ansible to affect things like load balancers or interact with Service Now, et cetera. And then what we're looking at coming up in the near term is coming back the other way. So there's already Ansible collections that allow you to run Kubernetes commands, but we want to put some specifically around ACM and your day-to-day management, your stand-up management. Sean mentioned things like putting clusters to sleep. That's what we do. We bring the capability to put an OpenShift cluster to sleep or to upgrade an OpenShift cluster. And so being able to drive those with a out-of-the-box collection instead of having to write a couple of kube resource commands inside of the Kubernetes Ansible collection is our goal with those changes. And so what we're really going to try to show today is the experience that you might have as a developer that needs a cluster and needs to work with their application, or as a DevOps who needs to manage multiple clusters, like a set of development environments, test environments, production environments, and the hybrid multi-cloud. And so this is where most organizations are landing that are doing cloud today, where it's not one cloud provider, but 2 or 3 or a whole gamut of them in different locations, in different regions around the world, etc. And so my name is Josh Packer. I'm an architect for this product, and I've also brought Scott Behrens with me, who's a product manager for this. Scott, is there anything you wanted to add to this?
Josh, you really hit it. As a lead architect, you've been in a key space for us, which is bringing together the goodies that Colin and Richard and Sean have talked about, and what we call the celebrity wedding of bringing all the OpenShift Kubernetes goodness that's on cluster and marrying that to the Ansible and everything else and beyond in the ecosystem. So it's really an exciting opportunity over the past 18 months that we've been able to turn out features in this space, and the market has really told us, you can't do everything on cluster. We have a lot of VMs. We have a lot of legacy applications and infrastructure we have to work with. And that's where ACM with OpenShift and working together with Ansible, we just have quite an awesome solution here. So Josh, take it away and tell us what we're looking at.
Absolutely. So we're going to jump at the demo, but I totally remembered I wanted to say something. Troy put a slide up at the beginning where he showed Ansible, he showed ACM, he showed ODF, the OpenShift Data Management Framework, and he showed ACS, the cluster security service. ACM is a glue that brings all of those pieces together. And so even though we're not going to jump into the storage, we're not going to jump into the security today, at least, those are pieces you'll see as we wander through the screens of my demo. And these are all integrations that ACM is bringing together. And then we look toward automating and extending with our Ansible integrations. So without further ado, so I said we would start with developers and their interaction and the need to grow their clusters. So before I provision a cluster and we get into that flow, I just want to talk about how this starts. You have any kind of OpenShift cluster. You have OpenShift on Rosa, ARO. You provisioned your own OpenShift. You go to the operator catalog. Operator catalog is Red Hat's defined way for putting software on your cluster. Not the only way. You can use Helm charts. You can run apply commands. But you go to the operator hub. There's an icon for advanced cluster management. You click that, you click install, and 8 minutes later, you're in the screen that I am logged in with the same credential that you used to access that cluster. So I started with one, I install Advanced Cluster Management, and I land here. We see these different pillars. Again, we talked about clusters, applications, policy, observability. So looking at the metrics of my system. We also have multi-cluster networking, and soon we're adding multi-cluster storage in that space as well. But let's look at clusters. As a developer or as an admin, I may need off the cuff, it stays 0. I have my first cluster. I want to expand into my second cluster. We'll ignore the fact that I have a bunch of clusters here already. I can click in. We've got this nice UI-driven approach where you can pick the cloud service, so the top 3. Then you have 3 on-premise, as well as a 4th, which is this assisted installer we use for our single node bare metals, as well as there's the original bare metal we've supported for a number of releases. The assisted bare metal allows you for a more customized image to be used in the experience. And the idea here is to be rolling out clusters at scale with that space. And so we pick the provider. We'll do one on Google for this demonstration. You use a credential. So I went over here on the credential tab and I preloaded my GCP credential. I actually have an Azure credential and an AWS credential for this as well, and a Tower credential, so that I'm able to talk to the Ansible automation platform. And so I click through here. I need to give my cluster a name. I'm just going to prefix it with my initials, and we'll call it Cloud Field Day 12. Cluster set, we're not going to go into the details here, but you can think of it as a resource group in Azure. It's a way of grouping together your clusters for allowing access to your fleet, or a grouping like a set of production clusters, a set of test clusters, a set of development clusters. It pre-filled in the base domain name from my credential that I had configured, and then I get access to which version of OpenShift. And again, this is a self-managed OpenShift that we're going to be deploying on GCP in this example. This is also curated in the sense that we continually update that for you automatically as new releases come out, as our Z-Stream, as we're patching vulnerabilities, etc. And then you can self-curate it if you want to limit your infrastructure to specific versions of OpenStack. Of OpenShift. We also have labels, and I'll just touch on this, is everything we do at scale, we do with labels. And so you're going to see as we look at these clusters, there are labels around region and location, cloud providers, what's running on it. But this is also where you're able to define things like, I want this to be a cluster that's part of production. So I might add a label that says something like usage equals production and add that in there. And so you can add line of business type labels. And why this is important is because then you can use these labels on that are on 1 cluster, 2 clusters, or 1,000 clusters to direct your security and policy compliance, direct your applications, direct your configurations. All of that can be driven at scale using a very simple labeling format, which ends up being very powerful when it comes to fleet management. So I'm going to keep going. I'm not going to I'm going to leave all the defaults, but it's going to go into the US East region here. I'm not going to play with the networking. I'm going to leave the default settings that came with it. You can put the system deploy the system from behind a proxy. And if you have that, you can configure those settings. And then you have automation where you can integrate with Ansible, which isn't set up for GCP at this point. So we'll just hit next and create. And so even though I talked for about 4 minutes, it took me about 20 seconds, maybe 15 to fill the data in. And this system is now going off and provisioning. And so that's great. We've got it in the cloud, but this is hybrid cloud. And so we have support for on-premise as well. And so when we start to talk about automation, we introduce this new tab where we can create a template that we're going to use. It's very similar to what we saw in the workflow, and you'll see workflow integration in upcoming releases so that you can take advantage of some of those new pieces that Sean was showing as well. But we give it a name, so we'll do VMware deploy here, if I can spell right. And we'll choose the hub that we want, the tower that we want to be leveraging from. And then we're able to pick our Ansible jobs. These are the same job templates Sean was showing before. And so here I can do a Service Now ticket that is involved with cluster creation. I can add that in there. I can also add in, so part of the problem with when you deploy a cluster in VMware is that VMware doesn't come with any native DNS integration, and an OpenShift cluster or other Kubernetes, you need an ingress point and an API point. And so I need, in this case, to be able to reach outside of my cluster space into my infrastructure and be able to configure a DNS record. And so here we're going to do a Route 53 record just to show an integration with an Ansible job. You can order these and flip them around if you need to. And you have the objective of being able to do pre and post jobs. So we're going to hit next. We're going to finish this off. And so I could go back through the UI, but that is not the only way to interface with the system. You can also provision with CLIs, APIs, and GitOps flows. And so we'll do a CLI flow here for the provision. So I've got a very simple OC command. OC is the hallmark for Red Hat that replaces kubectl, although kubectl will work in this instance as well if I wanted to run it. And I'm going to execute 2 pieces of YAML that are going to be deployed. That'll create a couple of resources in the environment, and those are the resources that are used to create a cluster. And so those can be done programmatically if you want to build scale automation. These YAML can also be committed to Git repos, both public or private, and integrated into the system as well to do the provisioning.
Yeah, Josh, take a pause there because that's a really key part of this. You showed off a very slick self-service type of user interface, a couple of inputs, bam, bam, and now I'm generating a self-managed OpenShift on Google. We actually think that the holy grail of all of this is the YAML-backed, infrastructure as code, GitOps technology, and basically just sending that YAML directly down the pipe. And that's what you're doing there in the vSphere example. You're creating that directly from YAML as code. Show us how you could have generated that in the UI.
Well, that's absolutely where it was. And I'm kicking myself for not having clicked the button when I was going through the GCP. But so for everything you choose here in the wizard, and as you fill it out, you can flip the YAML button and you will get the YAML pieces that go along with it to build it out. So I can create a template for a cluster, for cluster provisioning, for an example, on VMware, and then copy that YAML out, put it into Git, and have that applied then to my hub cluster, which is where this is running, and that will stamp out a cluster. And I can do the copy those files in Git and commit it again, and I get my second cluster or my third cluster or my fourth cluster. And so all of our UIs you'll see as we're going through this have that YAML button when I'm in policy, when I'm in application. So if you want to see what the YAML source looks like, you're able to pull that out and use that as a template to then build automation that you can run at scale. Or eventually even, you could feed that back into the Kubernetes Ansible collection as an example to be executed against the hub or other systems. And so here we see we've got the VMware system. I had defined it in the YAML. So we have a pre-hook this time, which is coming from the Ansible. And we actually have the launch out, which is going to take us to the tower. And the Ansible folks are going to be going, oh, he didn't upgrade to the preview release. And I was kicking myself too when I saw Sean show his display. But it's the same look and feel, give or take. And so what we have here is a ServiceNow integration where we're running an Ansible job. And that Ansible job is actually holding on to the provision. So it's not allowing the provision to go until the ticket that it created. So we'll hit here to refresh. See my cluster name here that was created. Till this ticket goes through at least a basic approval process. And so here I'm going to do request approval. It's going to ask me to pick the management team. I pick a management team and hit request approval. Now, again, because I'm admin and this is a demonstration, I'm just going to go down and be able to approve it. But it lists the set of approvers that are now attached to the ticket. And then one of those needs to go in. And I will pick the first one, which I think it was Luke Wilson. And I will click the approve here. And what that's going to do is then let us go through here in the log. We're going to see in a second that this goes to successful as the job completes. And actually what happens is because when you were seeing me in the UI demonstrate putting together my template, there were actually 2 pieces of Ansible that we were going to run. The first one was the ServiceNow ticket, which was a gate. So even though I wanted to provision, it didn't allow me to provision yet until somebody went through the ServiceNow and did the ticket. The next piece of automation it's going to run, and I don't know if it really came through, but this was grayed out for a little bit until the next automation job started. I'm going to click on this again, and it's going to launch me back to the tower, and we see we're running, and this time we're doing the Route 53. And so this is reaching out. Now Route 53, for the folks that have used it before, this is an AWS, the AWS DNS API, but we're calling it through to put a DNS entry for our public IP for our local VMware that we're taking advantage of and deploying here. And so that's successful. So if we go back, we can now see we've moved on to the next stage. And so now this is the actual cluster deployment going on. The system's going out, it's pushing, etc. So this is one way we go.
So Josh, let me pause there because I'm pretty blown away. You gave me side-by-side YAML, super awesome. And let's pause there and let the team catch up. Are you all up to speed on the creation of on-premise and cloud and Ansible hooks that are happening in here?
I actually have two questions. One is with vSphere in particular.
Absolutely.
What images do you have to have already existing in your vSphere cluster to make this actually happen?
So you actually don't by default. The system will pull in the vSphere, the image, and load it into vSphere. So OCP installer does that as part of its bootstrapping process. And so I didn't actually have to load anything into vSphere. And this is going on. Let me flip over. I think I have a window for vSphere open in the background. There it is. And so we see over here, so it actually makes a pull of an image onto the cluster side in what we call a bootstrap pod running on the hub, and then pushes that, if it doesn't exist, into vSphere, and then is going to deploy that vSphere template into the VMs we see that are just starting to pop up now, the bootstrap as well as the masters. And it's in our the CoreOS image behind the scenes that's being leveraged there.
Okay. And does this require any special features on the vSphere cluster? Do I need NSX? Do I need, no. I don't know, no? Okay.
You need a vSwitch. So vSwitch or NSX will work as targets for it. And VDS, so the distributed switch, all can work as the network target for the piece. Obviously, if you're just using regular vSwitch, though, you need to have the multiple ESX with the same vSwitch name across them, whereas VDS will cover all of that for you, and then SX just takes it the next step up. But yeah, in this system, I think it's running with a VDS, although we only have a single node, so we could have got by with the vSwitch. Right. And this is 7.0, but it'll work with 6.7 vSphere as well.
Okay. Those the pre and post hooks for running the cluster deployment.
Absolutely.
You showed some Ansible
yes.
playbooks. Are those just pre-canned included in the platform, or is that something I have to go out and write on my own?
So I pulled them out. So the service now is available as just a template. And so I literally just pulled it in and said, I want to put, variable X in the title, and I want to make the change request an approval requirement. And so it was a base template I took from Galaxy, like from online in the collection, and brought into my system. And then the same thing with the Route 53. There was a pre-can demonstration of here's how you create a DNS entry. And so I literally filled in the extra vars in Ansible with the details that we dynamically, maybe that's a good thing, a good piece if we're going to look into the depth of Ansible in the job, is we put in everything except for the secrets into the extra vars to take advantage of. So in the playbook where it needed to know the base domain, I was able to pull the base domain, out of this information that's dynamically populated into the post and pre and post jobs before it's run. So you do a little bit of manipulation in the playbook to say, here's here's the data you need from that variable to create the record, create the domain. What else was in there? It's the record value and the base domain values you had to fill in.
Okay. Awesome.
And so we dynamically load those, and you can take advantage of them then in your Ansible pieces.
Thank you.
I've got a question as well. This is Jim Jones. So I'm actually really interested in the vSphere part as well. But do you need like direct access to vSphere, or is this going to work with Cloud Director as well?
Right now, it's vSphere Direct. It's a vSphere Direct. So it's mainly targeted for on-premise solutions where you're running it. You've got vSphere in the data center at this point. I don't know if there's a Cloud Director direction yet or not.
Thank you.
I'm sorry. This is really awesome. It's really exciting. Just two quick things. The first one, what are the differences between the VMware vSphere cluster and a cloud cluster? Obviously, when we talk about like load balancers and networking, there might be some critical differences.
Yeah, no, of course. So, that is that you actually hit the main differences. So it is that there's like an ingress load balancer that AWS, GCP, Azure provide that are not going to be there for vSphere, which is why I was taking advantage of the Route 53 to be a DNS spray within the system. So there's no DNS, there's no DHCP management, IP management by default in the vSphere space. And so we used Ansible to take care of the DNS side of it, and we use DHCP servers in this case to take care of the DHCP side of it. And so we're just doing we do the DNS redirect down into the vSphere, and you hit the ingress of the actual cluster. And so in most cloud providers, there's just an extra step. There's a load balancer that sits in front that's a specific service that you get, but you also pay for.
Yeah,
you
exactly.
pay the charge on.
And that's where that question really comes from, because the other question that I have is that post hook connection that you were showing with that flow. If you were able to run Ansible at the beginning, could I run Ansible at the end and do configurations to that, say, Metal LB or something that I
Absolutely.
wanted to install?
Yep. Yeah. So all the details again about the system are included in that Ansible job in the extra vars. So then you can, depending on what you decide to run, you should have enough detail to be able to affect or manipulate any piece you needed. So you'll have all the networking that OpenShift was using during the deploy, all the storage data, all of the details around the resources that it used as well. And this exists not just in VMware. You can do these in the cloud scenarios as well. The pre and post hooks, we just use VMware because it's a good demonstration with the DNS, because all of that stuff is taken care of when you use a cloud provider. But that same set of dynamic data goes in both cases.
Thank you.
Okay, so I was going to import a GKE cluster, but in the interest of time, I'm going to skip that, but just point out that we're obviously Red Hat. We love OpenShift. We do all this provisioning around OpenShift, but we can import anything. And we will import, and you can do policy and application management against other, we often say the star KS, but the other cloud providers. So you see we have an EKS cluster. You can even see it looks different in the distribution versions, but we bring back the details that we know there's 3 worker nodes on it, and we know a bunch of details about it. We've also got the GKE, which I was going to import. I realized I didn't have an AKS in here, but AKS is also fully supported as an import, as well as when you're working with ROSA or OSD, you can import any of those managed service clusters as well. And the only part to show with the import, I won't go all the way through, but I would type something like GKE. You can add it or not to the cluster set. I used a name that was already there. We use GKE3. It'll generate, and there were 3 ways I could generate in, and it's still here. I run a command. So this is literally, I can copy to my clipboard. I connect to GKE on the CLI, and I paste, and that's it. You hit enter, it takes 120 seconds, 60, the agent's up, another 60 seconds, and the add-ons are up, and it's now part of your environment. You can also provide a username and password if you're token, if you want to import some other OpenShift. Say you have a bunch of OpenShift clusters and you're just starting into ACM and you want to bring them under management, you can do that as well. And then the last one is you can bring the kubeconfig from a star KS or an OCP and import it here. So not having to log into the command line, drop that here and it will import the cluster. And part of the key thing about importing the cluster is you can put the labels on it, is that once it's imported, all the different pieces, and here you can see it sitting in pending import state, all the different pieces are going to start to get applied to it. And so what does that mean? So that'll be my segue into the last 8 minutes, is around applications and our policy and governance and configuration. And so delivery of applications, delivery of our policies, security policies, and configurations, it's all based on placement. And placement is guided by matching labels. So again, you saw me put usage production as an example. Putting an application on the production system is as easy as defining an application. So we'll define an application here. We're going to do our our very cool Pac-Man demonstration. So we're going to do a Pac-Man app. I chose a namespace I wanted to put it in. I chose Git that I'm going to be pulling it from. I've got a bunch of Git repos that have the manifest. So these are all the resources that make up the app available. So I'm going to click on that. Now, because it's Git, it went out to Git. It looked up the branches and gave me some choices. I'm doing an Ansible sample, so I'm going to click there, and I'm going to pick a path. So I'm going to pick Pac-Man, but you can see, remember we talked about in provisioning pre and post hooks. I've got folders in my Git with pre and post hooks that I want with my Ansible app. I'm going to skip the commit hash. I'm going to skip the tag because I just want the latest and greatest. I'm going to leave the rest of these settings the same, except for my targeting here. So this is the placement, or how I target where I want this application deployed. So I'm going to type app Pac-Man on here. So the key is going to be app. the value is going to be Pacman. I'm going to hit save. And if you were watching, as I was typing in here, it was filling out details in the YAML piece on the right-hand side. And so this will take a few seconds as it refreshes, but we're going to get a topological diagram of what our Pacman app is supposed to look like, as well as an estimate of the clusters that we think it should go to. And so right away, we see it. We've got some routes, a service, a couple of different replica sets that are the actual pods, but we see there's a problem. And we see that the clusters is 0. This is because I put a flag in that doesn't, or a label in, I should say, that's not on any of our clusters. And so this is how easy it is to expand an app from 0. We'll do it to 1, and we'll go from there. So I'm going to pick this AWS cluster, JNP49. I'm going to edit the labels. We can see there's a bunch of pre-populated labels. I mentioned OpenShift. It's got regions. It's got production. It tells you the cloud that it's on. I'm going to add that label, app equals Pacman. I'm going to hit enter, and put it on the end here, and I'm going to save it. And so now I'm going to jump back to my applications. And I'm going to jump into the Pacman ACM that we were looking at. And so automatically, my placement's now gone green. I can see now there's one cluster, and I can see that we're getting ready to try some Ansible stuff. And then maybe we had a problem. Oh, haha. When I configured it, I left out the Ansible connection. That was where Scott was supposed to say, Josh, you missed it. So we'll put the tower JMP in there and we'll update it. But again, how easily I was able to tell what went wrong. I saw the error in it, as well as see the different pieces. So again, we've got Ansible running as a job. This is going to go out and create, this time we're just going to create a Service Now ticket that says we're doing some updates. Then it's going to, the app is going to be activated. So again, we get the launch out where we can go and see. I'm trying to be mindful of time here, so we may not go all the way into ServiceNow and to the pieces. But the point is that the point in all of this is that it's going to run that workflow, which is going to create the ServiceNow ticket. The app is coming online. It's going to run a post job, and this is actually the key part. It's going to reach out to F5 service, and it's going to create a shared route that's going to point back directly to this cluster that I'm just adding to the system right now. And so once that happens, it then becomes live, and I can go to a route and say, click on it, and I would see the application. So we're not quite there yet, but we'll give it a few seconds as it goes through. So my ServiceNow ticket has been created, and now it's launching out to go to the F5 to add the shared route for the system. And so
Josh, to be clear, these are Ansible jobs.
Yes.
You plucked out of Sean and Richard's catalog and said, F5 looks cool, ServiceNow looks cool, let's just use those.
Exactly.
You wired up a couple of variables out of those, and bang, you're able to integrate with F5 as your application is now moving out.
Exactly. So we're looking for it to create this JHDev, which is, again, a usable route that is for the application. And so, I'm going to speed up the demo a little. So I have it on one cluster. I'm going to push it to a second cluster. So let's push it out to GCP2. And again, it's as easy as in this case as just adding the application or adding the label app equals Pacman. And the system is going to jump out and going to apply it to the second cluster. But this works the other way as well. If I'm importing a new cluster or provisioning a new cluster, if I add the app Pacman label during that provisioning process, as soon as that's online, this application is going to get stuck there, stuck onto that cluster as well. And so you can see how very quickly this is a very powerful way of pre-configuring both day 0, but also day 1, the system, and being able to preset a bunch of apps that you want to go onto a fleet of clusters. And then the same applies in our governance, policy, and risk. And so we have these policies that we apply across the board to our systems, and that again use placement and labels to be able to reach out and figure out which systems do I need to apply these on, what do I have to do. And so some of these are configurations like activating the OpenShift GitOps, which is Argo, or the ACS that we mentioned, so the Advanced Cluster Security that came up. Other ones are things like security configuration. So we have etcd configuration. So this is making sure that all of my OpenShifts that are deployed automatically have their etcd configured. And so we see each of these being one of those. I don't think VMware is going to finish its provisioning quite in quite the time we needed to. But if it had, we would have seen this gone for at least a few seconds, it would have gone into violation, because in the default, it isn't configured if you haven't set the pre-settings for it. And so the other piece I guess I want to mention in the space, though, and just because we're tying this all together and we're running up against the clock, is that in the configuration for both our policy and our applications, you saw me run the Ansible jobs in application, we have the same capability in our policy space as well. And so for this, for an example, we can create a Service Now ticket, again, as a off-the-shelf piece we took because it's very easy to use, and we put the name of the policy that's in violation as well as other details about it. So what's going to happen is if this policy for etcd encryption goes into or out of compliance, it's going to fire off the job, create a ServiceNow ticket, could be a PagerDuty link or PagerDuty alert or a Slack message to the team. It's going to be able to fire off into that. Or you could take it a step further, and as Sean was saying, as we bring in these collections that affect change in Kubernetes, you could actually have it attempt to remediate the problem and make the change on your behalf. Now, we also, if it's a kube-specific check, offer that ability as well. So you can see here the remediation is in form. We have that ability to flip it over to be in force, in which case, if it finds something out of compliance, so a resource configured the wrong way, a set of settings that are not what are expected, you can enforce and change those back. Because part of Kubernetes is about always maintaining the desired state and moving towards that state. And it will continually try to get there. And when it can't, that's what this policy is for. It's going to light up your life. It's going to light up the board and tell you and show you exactly which cluster is having the problem, which specific piece is out of compliance. And if it's in enforce mode, you know there's a real problem and you'll have to go down there and look at it. If it's in inform mode, you can switch to enforce and then have that remediated on your behalf.
And what I love seeing there, Josh, is there's a warning at the top saying this is actually source code that's in Git. So we actually aren't going to let you change it here. You need to go through your approval process in Git to apply the enforcement. That means we're taking this policy as code and bringing that into ACM for desired state configuration management. Show me, Josh, where can I get some more examples of like these types of policies?
Absolutely. So we have this policy collection that is an open community. We have both a stable channel, so these are fully supported and a curated form of these policies that you can leverage. We've got contributions from Sysdig, we've got Converno, there's OPA gatekeeper pieces in here for use on your fleet of clusters. And then we have an entire community around community supported and submitted pieces as well. And so if you start to look at things like configuration, where there's a large number of these, and you can see by some of the dates that they're active development in it. And it's not just the ACM team that's in here. ACS is in this space, as well as a number of outside policy contributors as well.
That's it. Yep. So the exciting part for you guys, you're thinking about Ansible collections, and you're thinking about the areas where we're integrating with policies are another piece of this puzzle, and bringing that together with the compliance and standards framework that's baked into ACM. I think we're out of time, except for maybe any lingering questions. Thank you, Josh. That was at the pace of Sonic, I think.
Absolutely. Well, and I'm just going to mention it here, and maybe they'll bring me back in next year for another 30 minutes, is, we didn't get into GitOps. We touched on it there, pulling from Git, but this entire infrastructure is provisioned from GitOps. So this single infrastructure build out subscription, which you can use if you guys know what Argo CD is, or ACM subscriptions, we create this going through this create app. When I choose my GitOps repo, and I set it up to pull in the details, it built out everything we see, all those policies we saw that are applied to the system, all of these applications, except for the one that's at Pacman ACM, which I obviously created in front of you guys. All of that was applied to the system from that single point. And that's that infrastructure of code idea. And it lends itself very well. We didn't get into how do you back up ACM and move it, but it's that idea that if I wiped this cluster away, I could recreate it in minutes instead of hours or weeks or months. And it would look exactly the way it did today with exactly the same apps and the exact same spaces from scratch. And that's the key and the beauty of that GitOps flow. And hopefully down the road we'll get to come back and we can start to talk about that and how it lends itself just not even in Kubernetes but beyond there as well.
Last picture to leave us with, Josh. Click over into your Pac-Man because we never saw it spread out to that second cluster.
I gotcha. Yes. So everything is green. We'll hit the Route 55. We can hit the Pac-Man, and we got a playable Pac-Man here. And we see it's in Amazon East. And if we refresh enough, it would eventually switch over. Although I think it's using regional check on the F5. But yeah, you'll depending on if you hit this URL, we can make that available. We'll leave it up for a day. You can see it flip-flop back and forth between the two clusters. And that's the cool part is as you add and remove clusters, the Ansible job gets called and the F5 gets extended or contracted for those new cluster URLs. Again, reaching outside of Kubernetes and working with a service.